So welcome to the final presentation on solids handling for this year's JETCC Operators Class. I will be speaking to you about the final disposition or beneficial use of biosolids, particularly land application and composting. My name is Mac Richardson. I am currently the superintendent of the Lewiston-Auburn Water Pollution Control Authority. I have been there about 30 years, and so I've seen a number of things over the years, particularly in reference to biosolids, land application, and composting. So hopefully that will be some use to you. This slide is the original process flow diagram for the Lewiston-Auburn Water Pollution Control Authority plant. I have it included here for a couple reasons. First off, it's interesting to see some of the old dewatering equipment that was used originally at the Lewiston plant, such as removing grit from primary sludge, which had a number of issues and has since been replaced. It also shows the dissolved air flotation thickeners that were originally used for thickening waste-activated sludge. Those have now been changed out to gravity belt thickeners. Down on the right-hand corner, it shows a vacuum coil filter, which were widely used throughout Maine back in the 70s. I think all of them have now been replaced, but that old equipment was not very effective and quite energy intensive. But as much as anything, I wanted to draw attention to the fact that throughout this process flow diagram, you see little trucks shown. And that indicates that when these plants were designed, not a whole lot of thought was given to the final distribution of the biosolids. The designers felt, dewater it, put it in a truck, and then it's somebody else's problem. Unfortunately, it's not somebody else's problem at that time. We have to deal with it. Okay. As I mentioned just a bit ago, sludge was hardly considered in the design of treatment plants to start with, and that's what it was called back then, sludge. The name given to the residuals or the solids left over from treatment did go and underwent a name change to often residuals and now biosolids. And the name is important because sludge is a very generic term. You can have sludge in the bottom of your boiler at home or in your car's engine or in the bottom of a pond somewhere. That's all sludge. Biosolids is a term that is designed to specifically speak to wastewater treatment plant solids that have been treated to a degree that they may be beneficially reused. Now, the treatment depends a lot on how you're going to utilize those biosolids. So that's some of what we need to talk about. Of course, there have been many issues that have impacted the beneficial use of biosolids over the years. Dioxin, stacking issues for land applying biosolids, concern about the distance between the surface where biosolids may be stored on a farm field and the groundwater on that field. Certainly something that has impacted biosolids use for many years and continues to do so are the odors associated with biosolids. And then playing into that is the public perception, public acceptance, and concern about what else might be in those biosolids. So we'll discuss all of those things in a little greater depth coming up. As I indicated back years ago, nearly 3/4 or more of the biosolids generated in Maine were land applied on farmland as Class B biosolids, that is, as a replacement for manure in farming practices. Back in February of 1993, the federal government issued the Chapter 503 regulations, which established Class A and Class B biosolids that mainly deals with pathogen reduction requirements. Class B biosolids are biosolids that are an order of magnitude, that is 10 times, less than the pathogens that you would normally find in common manures, which makes it safe then for utilization under controlled circumstances on permitted farm fields for growing things like hay or corn, generally for feeding farm animals. If you get to a Class A pathogen standard, that means that you have reduced the level of pathogens in your biosolids to essentially background. I don't think you can ever say that biosolids are pathogen-free or they're zero pathogens, but they are no more dangerous, if you will, than going out into your front yard and digging up some soil. One would expect that you would find a low level of pathogens there as well. Some of the other things that the Chapter 503 regulations speak to are vector attraction reduction requirements. Those are things like flies or rodents that might get in the biosolids. But I was informed by one of the developers of the 503 regulations that those vector attraction reduction requirements were also intended largely to address odor issues, that the more stable you have your biosolids, the less odors they will generate, and therefore the less public opposition and so forth. The regulations also speak to loading rates, particularly for 10 heavy metals, some management practices, and some other things. The federal government overall, and the take-home message from the 503s was that the federal government looked at all the risks and determined that the risks from utilizing biosolids was quite low. So therefore, the 503s were determined to be a self-implementing rule. That is, there's not a lot of federal inspectors going out and enforcing on these. That does speak to the main regulations. That is, a lot of the regulation is left to the states. In Maine, biosolids are regulated according to these chapters here. For land application of Class B biosolids, you're really talking about the Chapter 419 rules, which are also impacted by the Chapter 418 rules, particularly some of the appendices there, and Appendix A of the 418 rules that has some limits for PFAS chemicals, which have become very important recently, and we'll talk about in just a little bit. Of course, there are other rules such as 409 that refer to processing facilities such as and composting facilities under Chapter 410, etc. I put this slide in to illustrate what can happen to a beneficial reuse program. I call it the Great Dioxin Scare of 1987. But if you see on the table here that LOPCA, Lewis and Auburn Water Pollution Control Authority, went from essentially taking all of our biosolids to farmland in '86, and then concerns about dioxins hit, and that got reversed to where just about everything went to landfill. At the time, the impact on the authority and the authority's finances was quite severe. And so it's important to remember that these programs are vulnerable and that we need to pay attention to public perception and how those things go. Okay, so I included this slide not just because it's a pretty farm picture from the state of Maine, but as a launching point to describe a few of the parameters and particulars regarding land application of Class B biosolids on farmland. In this particular case, dewatered cake at about 20% solids, which is about what typical manures are being spread on a cornfield. Using conventional manure spreading equipment that most farms have and is found around. It's important to note that the spreading is happening according to agronomic rate, that is, only the amount of nitrogen needed for the crop to be grown is being spread, and after taking into account any other sources of nitrogen, either from previous year's biosolids application or manure or anything else the farmer may be using. Many of the programs in Maine, or at least some, spread liquid biosolids. Those can be anywhere from 2 or 3% solids up to as much as maybe 5 or 6% solids, in which case the biosolids may be spread out on the surface of the ground so that it will percolate through the soil and then feed the crop. Or in some cases, an injection rig is used so that the biosolids are injected just below the ground surface. In the latter case, that can be very helpful with off-site odors. But in any case, the rate of spreading is for the needs of the crop being grown. Okay, so Class B biosolids are pretty heavily regulated predominantly by the Maine DEP, the Bureau of Solid Waste and Remediation. Each farm site needs to have a license from DEP, as well as the treatment plant often will have a program approval. That is an approval of its overall biosolids program. As I mentioned before, the biosolids are utilized on farm fields at an agronomic rate. In some cases, that rate is limited by phosphorus instead of nitrogen, particularly in watersheds of concern from a point of view of eutrophication and so forth. Soil tests have to be done yearly, and account has to be made of any residual nitrogen from application of previous years. There are setbacks that we'll look at a little bit more from streams and property lines and so forth. If you're going to stockpile biosolids for longer than 30 days, which is particularly important for a smaller facility, then you need to have a specifically permitted stockpile site on a given farm field. One of the things that is of concern there is the distance between the ground surface at a stockpile location and the depth to groundwater, so that we are not degrading groundwater from storage of biosolids. All these farms have to have nutrient management plans, and an annual report needs to be submitted to the department by the wastewater treatment facility, and if any other materials are utilized for fertilizing the crops being grown, those need to be accounted for with those nutrient management plans. This slide is included in order to demonstrate a classic or a farm field and some of the limitations that are involved in using a permitted farm field. For example, at the bottom of the slide, you can see that there's a 300-foot setback from wells from private residences. There are also setbacks from perennial and intermittent streams. You have to set back or not spread on areas where the slope of the land is too great. You can see there are a couple stockpile locations on this field that are designated on the map. There's also some wet soils up in the upper right-hand portion of the slide where there are some setbacks. So there are some significant limitations to utilizing Class B biosolids on farmland that do not apply to manure. Matter of fact, in some instances, farmers will go and spread manure in setback areas, whether that is safer than spreading biosolids is certainly open to question, but those are the rules under which we play. So what is going on with the land application of Class B biosolids in Maine? When I started at the Lewiston Auburn Water Pollution Control Authority in the late 1980s, early 1990s, again, most of the biosolids produced in Maine was applied on farmland as Class B biosolids. As of 2015, only the few facilities that are shown here were still land applying dewatered cake, and then of course there was a fair amount of liquid that was being utilized. Of course, most of that is in Aroostook County. Some reasons for that really had to do with some changing DEP rules, particularly concerning storage and stockpiling of biosolids, but also a lot of public perception around things, as I mentioned earlier, dioxin, odors, just the unknown and the yuck factor that came to play and that kept a lot of facilities away from continuing to utilize Class B biosolids. So if we are not doing a lot of land application on farmland any longer, what is going on with biosolids in Maine? A significant amount of the biosolids are being composted, and although 2014 is quite a while ago, a good part of what is going on is that a lot of biosolids are being composted at the Hawk Ridge facility in Unity, Maine, that is operated by Casella Organics. Soil prep is no longer in operation. The Lopka facility has been up and down the last couple of years and is in a state of transition. We'll see what happens with that. There are 15 other facilities that were composting some biosolids, 7 of those being private. Sanford started up composting in 2017, which I see as a good trend. Pricing for the compost, which is valuable and which a lot of people love, it's certainly been our experience in Lewiston Auburn, is anywhere from free to $25 or more per cubic yard. With something like compost, a fairly low volume or a bulk commodity, transportation and handling and hauling issues are huge. Every time you move the biosolids, it costs you money. The transportation is certainly very big. There are significant sales out of state. There's quite a bit of sales to Massachusetts, for example. I know that Casella Organics has done a lot of that, as well as Lewiston Auburn. However, with some of the issues such as PFAS, we'll see what the future holds for composting. This is simply an aerial view of the Lewiston Auburn Water Pollution Control Authority compost facility. It is located in South Auburn on a 118-acre farm. It's an in-vessel composting facility as opposed to, say, a aerated static pile, which is one of the more common ways of composting, or a windrow facility. Sanford, for example, uses the aerated static pile method. The Hawk Ridge facility in Unity, operated by Casella Organics, is a HECOM tunnel, which is sort of a improved and enclosed aerated pile kind of composting. One of the things that's interesting about the Lopka facility shown here is that being on a farm site helps to deal with the odor issues involved. In the foreground of the picture, you can see a biofilter that was used to control odors. That is one of the things that is changing concerning the Lopka compost facility, and maybe I'll get a chance to talk about a little bit more in the future. However, odor control at composting facilities is something that needs to be given great consideration, as when we put this facility in back in 1993, many facilities around the country had been closed due to odor complaints from neighbors, and that was the biggest problem with composting at that time. So, some keys to success in running a biosolids program. First of all, you really need to have robust public relations and have a little bit of a thick skin, because no matter what you do with your biosolids, there are going to be people that second guess those decisions, whether it's abutters to land application sites or abutters to a compost facility possibly, or someone coming up and just saying, gee, what do we know about this? Or isn't there something in there that might be a problem? Certainly, we didn't even think about PFAS chemicals in the 90s, and those have come up to be huge recently. Of course, you need to do testing and make sure that your biosolids quality is the very best you can make it. And you need to very strictly abide by all the rules and regulations, and to be able to demonstrate that to people. I would like to throw in that flexibility in your operations and having a backup plan is very critical. And over the years, biosolids management has been largely dictated by odor. Certainly, that is what generates more public complaints and has shut down more programs than anything else that I can think of. But in all cases, it is something that needs to be managed carefully, and you need to stay on top of. Slide hopefully has some humor value with it. This is a sign that was put up in a residence adjacent to where we ended up building our compost facility. But during the permitting time, this resident put all kinds of signs up in his yard indicating their opposition to the compost facility. And we've had to deal with that in a number of instances, whether it be land application or composting. In any case, be ready, because you will have to address issues from residents. I won't spend much time on this slide. This does show the biofilter that we were using at our compost facility. Again, I think odor control is absolutely critical if you are going to be looking into biosolids utilization, whether that be from composting or drying or even dewatering. Odor is a big issue. Interestingly enough, we have found that after anaerobic digestion, we think, and we've done some pilot testing that shows that we can compost our biosolids after anaerobic digestion on our fairly forgiving site in South Auburn without having to utilize our odor control system. That's currently something we're working through the Maine DEP with, and we'll see how that turns out. And I won't spend a lot of time on this slide. It just really shows our compost facility and how we are interested in a half-mile radius around the compost facility, because that really tends to indicate where odors might impact other people. The more space you have, certainly the better, and that has served us well over the years. And then you have PFAS. This is an absolutely huge issue for wastewater treatment facilities, and at the present time there are not a lot of good quote-unquote solutions to PFAS. So what are they? PFAS are per and polyfluorinated compounds. I've been told there are greater than 4,000 different compounds that fall into the category of PFAS. They were very, very widely used in consumer products, in things like water repellents for clothing, in microwave popcorn bags, and dental floss, and nonstick cookware, paper to wrap deli sandwiches. It goes on and on and on. Stain-resistant carpeting and water and fire-resistant upholstery fabrics. They are very interesting in that the fluorine and carbon bond is a very, very strong bond, and therefore these compounds break down very slowly in the environment. They are not, as sometimes called, forever chemicals. They do break down, but it does take quite a long time. Of course, they were widely used because of their properties that shed both water and resist oils. That also means that their fate or their movement in the environment is somewhat difficult to model and to predict. Current treatment technologies for PFAS, importantly, do not destroy the compounds. They just concentrate those compounds onto another medium, such as ion exchange or carbon adsorption. You still then have those PFAS compounds that need to go somewhere, typically to landfill. Of course, once those materials are landfilled, then you have leachate that is generated that still contains a good portion of the PFAS. That has to go somewhere. Do they go back to the treatment plant? That's a big issue, really. It's interesting to see how we are going to deal with these compounds going forward, and there will be more on that. So what are the standards and what are we dealing with in terms of PFAS and biosolids? The EPA has a health advisory at 70 parts per trillion. That is a drinking water advisory only level and applies to two PFAS compounds, and those were the two compounds that were originally the most widely used. They are 8-chain carbon compounds called PFOS and PFOA. Those two compounds, interestingly enough, were phased out about 10 to 15 years ago in most countries, and the concentrations of PFOS and PFOA in our bodies, because we all have a body burden or background level of these compounds in our tissues, have been declining for years. Those are, though, the two compounds that are most widely regulated by by states around, and are two of the three compounds that are currently regulated by the main DEP Chapter 418 screening standards, which have a combined level of 7.7 parts per billion in soils. That's difficult because background soils typically have 1/3, maybe as much as a half of the main screening standard existing, even if no biosolids have been used or there's no known source for those levels, those PFAS compounds in the soils. So it's a very difficult thing when we're talking these very, very low standards. And these standards do not allow you to apply biosolids, Class B biosolids on farmland if you are above that 7.7 part per billion standard. The standard of 7.7 combined ppb for PFOS and PFOA also applies to compost. And most composts in the state of Maine have just by a bit exceeded that level. There are some things that DEP has currently allowed, and that is for some cumulative loading rate calculations to happen for both Class B and Class A, such as composts materials. So really what the preparer of biosolids needs to do is to show that after utilizing either the compost or the Class B biosolids, that the level of PFAS remaining in the soil after use will stay below that combined 7.7 part per billion. Sometimes that's kind of hard to show, but we're doing our best to work through that. One question then is, which of these alternatives carry the lowest risk for PFAS? And it's not entirely clear that going to landfill is a low risk alternative, given that those PFAS chemicals are still there and the leachate will have to be treated. One thing that stays in my mind, for example, is that way back when with the RCRA regulations of the 70s, if you put something in a landfill and it is later on shown to be a problem, then anyone that has put any of that material into that landfill is liable for cleanup and for whatever costs come down the road, whether it's now or 20 years from now. So it's a difficult thing. The other thing that's interesting is that industry is still making water repellent clothing and stain resistant carpets and so forth, and they have used replacement chemicals, sometimes called Gen X chemicals. These are typically 6 carbon chain and lower molecules that still have fluorine atoms on them, but they have been tested less. The initial indications that I've seen is that these replacement chemicals may be as toxic as the PFOA and PFOS. However, they may also be more mobile in the environment. So it's hard to know if this is a better situation than we had in the past. But this is certainly a developing area that you'll have to keep your eye on going forward. So here's my wrap up. Certainly, many of these things could be talked about at much greater length. And if any of you want to get in touch with me, if you have specific questions, I'd be happy to discuss them at greater length. But I do want to say residuals management is one of the most expensive pieces of operating a wastewater treatment facility. After typically personnel, it is probably your biggest expense, and it is one of the things that you can perhaps make the greatest impact on to reduce your costs. Many facilities in the state of Maine have chosen to outsource biosolids management. That is, put it in a truck and send it off to landfill or to a third party such as Casella Organics operating the Hawk Ridge facility, and certainly that's an alternative. I guess I would caution anyone to remember that these biosolids were generated by your facility, and if there's any problem, they will come back to your facility. So you need to stay involved whether you are using an outside firm or not. I would like to say that these biosolids are nutrient rich. They really deserve to go back in the soil. That is nature's plan, nature's cycle for carbon, nitrogen, phosphorus, etc. And it's really a shame when these materials that have a lot of very beneficial qualities are not utilized, but are disposed of and just thrown away, such as in a landfill. Odor issues have been and continue to be a key consideration, and they have a great impact on how the public sees whatever biosolids alternative you have decided to come up with. The PFAS issue is far from settled. Many states were scrambling before the COVID-19 thing hit to come up with regulations and very low limits in many cases. I really wonder if this is not going to turn out to be something like dioxin, where we say, well, or we determine that although PFAS chemicals are not great to ingest in your body, they are a fact of life. They exist out there. And of course, it's important to note that wastewater treatment plants do not make these chemicals. We only reflect the society in which we operate, the background levels that are everywhere. One of the studies of background dust in households showed that in many cases, the PFAS levels in dust were an order of magnitude, 10 times higher than what would be allowed in soils, according to the 418 rules. So it's really interesting, and it's difficult at this time to see what's going to happen with the PFAS issue. One of the things that looks promising is some of the new belt dryers that are on. Those will get solids up to about 90–95% solids. And as you'll see in some of the mathematical exercises that we've included, the amount of water in your biosolids is very critical to their final destination and what you do. And they certainly greatly impact costs for hauling. So the better you can do at removing water, the more alternatives you have. And with that, I will end this, and I hope that you've gotten some good information out of these slides. Thank you.